Hello there, U8s, Mr. Herman here, and this is an essential assessment lesson on surface area and volume of cylinders. This will be the last skill that you guys will be looking into in the measurement topic for essential assessment, and then after that you'll be attempting your pre-test. Now, the learning goal for this lesson is to look into the formulas of the surface area and volume of a cylinder. And the success criteria is to be able to calculate the surface area and volume of cylinders and solve related problems looking into capacity and the conversion of volume to liters of some sort. So that's the learning goals and success criteria for this lesson. Now, the essential assessment skill that you'll see is on a tricky caliber. It is straying towards a year 9 level. So if you find a lot of these questions a bit too tricky, that's okay. This is the last topic that we're looking into anyways. Now, before we delve into some of the examples, and there's 3 examples I'll be showing you, I want to look into the cylinder volume and the cylinder's surface area, and I want to make sure that you guys are well aware of what volume and surface area actually entails. So volume, just for any form of shape that we have, and we'll get to the actual cylinder itself. So in one dimension, we're so used to a length of some sort, say from there to there. This here is a one-dimensional measurement, and we can figure out what this length is either using a ruler of some sort or tape measure, or it doesn't matter. This is one dimensional, and this here is a length. Okay, and then this is one dimensional, 1D. And then from length, we can add another dimension. And so when you're given a length of some sort and a width, you want to find how many smaller squares, depending on what your unit measurement is, whether it's centimeters, meters, kilometers. You want to figure out how many, say for instance, squares are in there. This here is called area, and this is 2-dimensional, length and width. So 1-dimensional, just getting a length; 2-dimensional, getting a length and a width. In this case, there are 20 improportional and badly drawn squares, but this is 20 because this is 5 by 4, which gives me 20. And then extending on this, when you have a length and a width, and you add another dimension to this, like this, and you get a rectangular prism. This has a length, this has a width, and this has a height. So this is length, this is width, and this is height. And what you're looking for is how many 3-dimensional blocks can fit within this 3D shape. So think of those little blocks that look like this. How many of these can fit in there if we're given a length, width, and height? This here is volume. And you can imagine this is 3D. So length, we're looking for individual 1-dimensional lengths. For area, we're finding how many squares can fit in a 2-dimensional shape. And for volume, we're looking at how many of these 3D little shapes can fit in a 3D prism of some sort. Now, there are different formulas depending on what type of shape that you get, what type of prism. We're just going to be focusing on the cylinder. So the cylinder has a special property. It's circular, and the circle is consistent throughout the height. So you can have a big circle, a small circle, and then a consistent height. If you have that, that is a cylinder, kind of like a toilet roll. And the volume of a cylinder is found by multiplying the area of the circle, also known as a circular cross section. We call it a circular cross section because you can cut it at any point, provided that it's horizontal, and it will still remain a circle, the same size circle. We get the area of that circle, and then we just multiply it by the height. And so the volume is just the area of the circle times the height, and we know the area of the circle, which is pi r squared, and we multiply that by the height. So volume, V, is equal to pi times r, which is our radius, times h, which is a height. And just like any formula, you give me a radius, you give me a height. And remember, the radius is from the center of the circle to the edge. You give me a radius, you square it or multiply by itself. You give me a height, you multiply them together, and then multiply that by pi, 3.14. And you can get your volume, or in other words, you can find out how many of those little squares can fit within here. Now obviously we're not going to get a whole answer because we're dealing with circles. You can't fit exactly an exact amount of those small little squares within there. There's going to be some little space maybe on the sides and on the edges, or maybe even on the top. So chances are you're going to get a decimal answer of some sort. Okay, we're going to be looking into cylinders and the volume of the cylinders in the next set questions. The other formulas we'll be looking at is a surface area. Now surface area is taking a 3D shape, and again I'll show you an example. Say for instance I have this shockingly drawn shoebox again, and we know this rectangular prism is made up of 6 sides, front, back, 2 sides, and the top and the bottom. So this is 6 sides, and what we're doing is, for a surface area, we're getting the area of all 6 sides. So the top, front and side, and then the other side, the back and the bottom. And so you get the area 1, 2, 3, 4, 5, 6. You add all those areas together, and this will give you the total surface area. The total surface area. Now again, depending on what type of shape you have, say for instance, you were to have maybe a pyramid of some sort. A pyramid, obviously the total surface area for this is going to look a bit different because it's going to be made up of 4 triangles, front, back, side, side, and then a square base on the bottom. So your formula will be a little bit different because you're going to be adding up different size shapes, and again you'll be given measurements in relation to what this shape is, and then using your relevant formulas to obtain the area. Now for a cylinder, the cylinder surface area is made up of 3 shapes. 2 shapes, the top part, which is a circle, and the bottom part, which is also another circle, and those circles are the same size. And then you have this strip that goes around the outside. So imagine if you had that same toilet roll, and you cut a line straight down the middle, and you stretched it out, you'll end up getting a rectangle. And the rectangle will have the dimensions of length times width. But in this case, it will be the circumference of the circle. That will be the length, and the width would just be whatever the height is. And the circumference of a circle is 2 pi r. So that's where you see that 2 pi r at the start, and this is being multiplied by its height, which is h. Area of a circle is just pi r squared, like we saw before. And what you'll be doing is obtaining 2 lots of 2 pi r. So 2 lots of 2 pi r, that's where the 2 comes from. And you're adding 2 pi r h, which is 2 times pi times r times h. So again, a lot of this can seem quite intimidating or quite confusing, because remember, this is Year 9 work that you're delving into. You're just going to remember that when it comes to whatever you're looking for, if you can give me a radius and a height, you can just plug it into the formula and you let your calculator do the rest. Okay, so let's delve into the first example here. So this is the first question that you'll see on your essential assessment skill. And this is, what is the correct volume of this cylinder? And remember, this is the formula for your volume. You will need your scientific calculators ready for this because you will be using the pi symbol. Okay, so what is the correct volume of this cylinder? We have a cylinder that has a height of 4 and it has diameter. Height of 5, repeat that, height of 5 and a diameter of 4. Now, we need to use pi r squared h. We need to use the radius, and our radius in this case is half of what the diameter is. So that's 2 centimeters. So our volume is this pi times our radius, which is 2. Remember to square it, times our height, which is 5. And all you've got to do, all I've done is just replace what letters I know from here within the formula. So our volume is going to equal, to get pi, it is shift and this time 10 to the power x button. This will give me a pi. You can see a little pi on the top, multiplied by 2 squared. I know this to be 4, but let's just use 2 and that square button there. 2 squared, multiply that by 5. When you get an answer, it will show you what this answer is in relation to pi. All it's done is 2 to the power of 2, so 2 squared, which is 4. 4 times 5 is 20, and it's just left it in terms of pi. We don't want this. We actually want the proper answer. So what we're going to do is we're just simply going to press the SD button over here, and this will change it into the decimal form. So this is 62.83. So let's look at our answers. 62.83. That is our solution there. Now 62.83, you'll notice that there's this little 3 up the top. This is just to indicate that we're dealing with volume, that we're dealing with 3 dimensions. We're finding how many of these little blocks like this can fit into a cylinder that is this size. And this is saying, well, 62, nearly 63, but 62.83 to be exact. That is the formula that we use, which is not that tricky. Once you know what the formula is, you give me a radius and give me a height, I can give you what the volume is. So a lot of the starting questions have to do with this. The next set question, you'll be looking at trying to find the surface area of the cylinder. So it's the same cylinder. This time we're trying to work out what the area of the 2 circles are. So the top one, the bottom one, and what the area of this strip that goes right around is. Dimensions are still the same. We know the radius is 2 because the diameter is 4, and we know that the height is 5. But this time we'll be plugging in the numbers into a different formula. And again, if you give me a radius and a height, we can just simply plug this in. So SA, which is surface area, is equal to 2. I'm going to put square brackets just to indicate where the first one is, and then I might change the color for the next one. This is 2 times pi times our radius squared. Remember, our radius is in this case again 2 centimeters, so 2 squared. That's our first part, and then we're going to add 2 times pi times radius, which is 2, times height, and our height is 5. Now, if you're unfamiliar about why the formulas work the way that they do, don't panic, just copy the formula as it is and then replace what you do know. Because all we care about at the end of the day is making sure that we can get the correct answer. Now, obviously, I want you to know where these formulas delve into, because that's what the reason why we do mathematics. But considering that we're on an online format, it gets a bit tricky to explain it. So for now, let's just put this into the calculator. So let's clear out our question. And I'm actually going to put brackets around these 2 different sets to indicate that this here are 2 separate things we're going to be working out, and then they're going to be added together. So 2 times pi, remember shift and that button there to get the pi, times 2 squared, close bracket, and we're going to add this to 2 times pi times 2 times 5, close bracket. And here, this will be 28 pi. Remember, I want this in decimal format, so this is 87.96. This is equal to 87.96 centimeters cubed, or cubed centimeters. 87.96 is that solution there. So be careful when using this formula that you make sure that your radius is half of whatever the diameter is, and then when you're putting it into the calculator, you're putting brackets around these 2 to indicate that you're working these out separately. Now the last set of questions that you'll be seeing has to do with volume and capacity. Now capacity has to do with converting whatever measurement you get in terms of volume into either milliliters, liters, or kiloliters. And this is a little table that we'll be using here from question 11 onwards. Now this will be working into two different parts. The first one is working out a certain volume of a certain part, and then from that conversion we're going to convert from that answer, we're going to convert that into a capacity. So this question here is saying which volume of paint has been used from this paint tin. So in other words, there is paint within this tin and a small section of it has been used, and to carefully show you how much of this has been used, it's only a small portion. It's only this amount within here, obviously not to scale, but 3 centimeters height of paint has been used. What we need to do is find out what that volume is, and then convert that into capacity. So the volume of a cylinder, and remember we can backtrack to this here, the volume of a cylinder, let's put this to the left, pi r squared h. So volume is equal to pi r squared h. Give me a radius, square it, give me a height, multiply them all together, and then multiply that by 3.14, you'll get your volume. So this is pi times radius. So if the diameter is 14 across, the radius is half of that, which is 7. 7 squared times the height, which is 3. And here, let's put this in as pi times 7 squared times 3. And we'll press SD to convert that. This is 461.81. And this is in cubic centimeters. But you'll notice this answer is not here. We've got something that's similar to it, based on the fact that there's a 4, 6 at the start. But just to make sure, we're trying to look for the right conversion, and this is the saying here that 461.81 cubic centimeters. This is closely related to this one here. Now it's not exactly 1000, we're nearly there. Alright, so if this was exactly 1000, we would have 1 liter. So we know we've got less than 1 liter. To be exact, we've got 0.46, and this 8 will bump this to a 2, 462 liters. Meaning this right here is our answer. Okay, so what we had to do is just find the right conversion, and then use a bit of logic to indicate what is this in liters. We're not all the way to 1000. We're just a little bit under this. If this said 1322, then obviously we'll do the right conversion. It will be 1322, so 1.322 liters. But because this is less than 1000, it would be less than 1 liter, so 0.462 in this case. And that's it. That's all there is to these type of questions. Question 11 onwards has a lot to do with capacity. To make sure you know how to answer the set questions towards the end, use this conversion chart here to help you out. So remember, this is a skill, find surface area of and volume of the cylinders. Go ahead and attempt this skill. This will be the last skill that you will need to attempt before we try our post-test rather, which will be on the Wednesday. Best of luck, guys. You know where I am if you need any help. Talio!